Okay. Test microphone. Okay. Oh, I'll turn down some lights. Ah, that's better on the eyes. This shot's kind of crap. That's what you get. Do you hear me, Steve? First thing I'm going to do is disconnect everything. Is Jeremy still on? Loud and clear. Alright, is the wind noise bad? I got the little fan on. It's probably blowing pretty hard. I mean, the fan's not loud, but I didn't know if it was blowing into the microphone. He's still on? Okay. I probably can't stream at the same time. He'll probably have the same problem, so I'll just have to catch up with him another time. Basically, I'm going to attempt to connect some things here. To some things here and see what happens. First things first, I need to find my variable control transformer, which I don't quite know where it's at. I think it's in the bottom of this. Oh yeah, I gotta clean this stuff up. Okay, I should clean that drawer out eventually. So, I'm not going to use this coil. Although no, I'm not going to use this one. I should probably use something completely different anyway. Oh well, let's clean this mess up. There's that coil. Could just do that. This away. Yeah, okay. Let's put this over here. Put the... Jeremy! Don't burn it up! Jeremy, I am going to put this inverter right on this sucker. Are you going to stay up for a while and watch me? Are you listening? I don't know if you quit streaming. I don't know if I can stream on this computer out here while I'm... or down, watch you while I'm watching. It might work, I don't know. Let's see if I can find a... This cord has... Oh, that's that. I left the darn power cord at work that had the plugs on the end of it. Now I have to jerry-rig something. That kind of sucks. Well, I really don't want to cut the end off this cord though. Yeah, I don't know how long this is going to take me. I need to run through a few procedures before I just goes balls into it. I always hit my head on that. This has a heavier gauge wire on it too, I think. Let's see. I'll actually take this cord. Just use it. Oops. Crazy thing is this, I'm pretty sure this inverter board will take in like any voltage. Wow, that goes straight to that, and negative goes through that jumper. That's not that big of a jumper. Straight to the this capacitor. Oh, and the IGBT. So this is like the tuning-ish capacitor there. That one and that one. Oh well. It already smells pretty bad, so whatever. But we're going to try to find out the minimal amperage input that I need. So, yeah. Got some squigglies on my AC again. Okay. Darn. Gonna have to slightly reconfigure this coil too. Oh crap. We have to do several things. Alright, this is going to my amp. Disconnect that and plug it into the signal generator. USB cameras can be over there. Oh, this bright freaking light. Go away. Okay. Oh, it's so cozy in the, like, not real bright space. Yeah, I love it. Let's make this a little bit smaller. Make this a little bit smaller. Oh, come on. There's the edge of the camera. Alright, so now you can see what I got. 99% of it. Steve's making pizza. Okay. There are several things I should do. This terribly stinky smelly thing. And this. Pretty sure this actually has one's why are they different? Oh, I bet that's for the variable frequency range. One is a 560 picofarad, 5,000, so 5.6 UF, I think. And the other one's an 8.2 UF. I got everything written, well, not everything, just those written in picofarad. So we have a 4.5 UF and a 0.23 UF capacitor across the main. Man, the input goes straight in through the DC, through that inductor, probably a limited, choke limiting. I'd imagine it's not for anything else, current limiting, right into the primary, so that's what I'm going to do. And then the output, it's a little different the way the output works, but what I should do is connect this coil. It has no core anymore. That's kind of a problem. I guess it won't hurt anything if the coil's not connected. It's not going to damage anything. But the feedback is going to be all screwed up. Okay, I see. There it is. Oh, screw it. We'll just connect it to the Rodin coil and then we'll play with it. First things first. Let's connect this thing up.
Oh, where is this wire supposed to go? It's supposed to go on there. But either A, broke off, or B, something else. Looks like we'll be soldering that back on real quick.
soldered up, boys. Balls in. You have to split the screen. Watch this. Then R. Solder.
Oh, this has a few good things.
This is 10 amps. The fuse that this was connected to was like 18 or something. Are we hot? Yeah, we're hot. Alright. Solder this wire back on. Apparently it fell off. Alright. For whatever reason, it decided to fall off. So, now we have to remember how to work this thing.
AC goes where?
I know
AC should go across here, and then my line voltage is from one of these to one of those. These two screws are the only ones loose. I imagine those are the ones we want.
I really can't remember very well. Can't believe I don't have another cord laying around here. Oh yeah, I did. What did I do with it? There it is. So obviously we're not going to connect the ground, because if we connect that, then we'll have problems. Yeah, I'm serious. Never connect the ground to anything you don't want to be grounded. Does that make sense? Ow! Stabbed me. Alright, we will cut the ground wire off because, well, you know, we don't need that. This a little bit longer. to be able to plug it into there, and I have other wires out here. Let me grab. Okay, I use the extra wires from the microwave. So actually we can use this plug. Just cut this off. Don't need that anymore. Or we could use this plug. Which one do we want to use? Exact same. We'll just use this one. I think this is the original one that goes to that anyway. So what we're doing is we're trying to find out the minimal input voltage that this thing thinks it needs to operate. Because I want to try to make this input very low. So I could actually, you know what I could do? I could put 120 volts into the circuit side that it needs to work, and then disconnect that. So actually, if I wanted to, I could disconnect cut the trace and input a much lower voltage, so I'd have a voltage control, but the rest of the circuit wouldn't know any better. So we'll leave it alone for now, but then if I wanted to, I could make it completely adjustable, because the AC incoming, I don't think it matches up or anything funky. So we're going to connect these two wires. It's actually going to that one. Those are the wires that were loose, so alright. There's our neutral and our hot wire. output voltage. The screwdriver's too big. This one's too small. This one's just right. Big bear set. Anyway. This is our output voltage. And of course we have no fuses, but I am going to plug this into a breaker, one of these things. This has a 15 amp breaker in it. So we got a little bit of extra security here. Plug this over here somewhere. That goes to all that stuff. That goes outside. I guess I'll turn my fan off for the moment. Alright. 15 amp to a 15 amp. Thingamabob. Set this over here. Get this out of the way. Okay. So let's get a voltmeter. Check our output voltage. This thing's plugged in, so I should be careful. At least a little careful. It's really a bad spot. Let's try to get over here where I can't touch all the contacts at once. Just remind myself. This all is live circuitry. Okay. Let's check the AC output voltage. So, AC output from here and here. Alright. So this should be max voltage. Still 21. Oh, it's because it's backwards. So actually, if I'd connect those a little different, I could get if I connected it there, I could get even higher voltage, but then less amperage. Alright. So, we're good there. I'm actually going to leave this connected because I want to actually know what the voltage is at all times. Okay. Now, getting too hurt, I actually need to make this Rodin coil a little different. This Rodin coil is about to go under some extreme conditions. This shall be fun. Now, cool thing is I can rectify the output. Actually, I don't even need to rectify the output. Yeah, actually, if I rectify the output, I could feed it right back into the DC line going into the inverter. And then I can unplug the power cord and it'll just run by itself. Wouldn't that be amazing? That's what's about to happen. You're about to watch history. All because somebody threw their microwave on the side of the dumpster. They didn't throw it in the dumpster because they knew I was coming. Because this circuit is a self-ish tuning, load-dependent circuit. So as long as it doesn't just go poof on the first round, we should be able to do some pretty interesting things with it. But first things first, get this darn heat shrink off. This is good heat shrink. I think this is my heat shrink that's on that roll I have there that's from the yard sale. It's crazy to think that the driver for this is like, the driving coil is like super, like no resistance. So it'll actually have probably too much resistance when I connect this to it. I might even solder the Rodin coil right into the circuit. What can it hurt, right? Good thing I took all that time metering all of these and finding out which one was which. I wonder if I should, I guess it doesn't matter, but... Okay. Let's desolder all of these. If we're talking Litz wire, oh, that gets hot fast, which we are. And this is not very fine Litz wire. The wire on the driver is pretty small. Drive coil. So the skin effect plays a major role in this, and by not having such fine wire, it'll really affect our skin effect. So much for all the work I put into labeling and all that crap. Okay. primary circuit. Smell something that's warm. It's not my transformer. Must just be my solder. The primary circuit is self-tuned. Has nothing to do with the output. So I think what I'll do is not put anything on the output. I can connect some light bulbs or something, I guess. Jeremy went poof. He might be back. He's back! Welcome back, Jeremy. I did a good job putting these together. Switching computers and stuff, it says. Yeah, take as long to solder these together. Actually, I think it took longer to solder these together than it is to pull them apart. I mean, it's taking longer to desolder them. How many I got? 3 more? 4 more? Jeez. Remind me not to solder them so darn good next time. Ow. Somehow a piece of that landed on my foot. Alright, we're almost there. Luckily, we don't have to check all these. I got them bundled so I know exactly which one's which. It's easy. Okay. I'm gonna leave mark. What a pain. Okay. So, here we are. Ken, is Ken watching? Ken, I'm going to try not to blow up the shop. And my coil and my circuit. And my transformer. Basically everything in here. That in these holes. A little more crap in things for sure. The inductance is going to be different than the factory coil. I have no idea what's going to happen right now. I think before I turn it on, I'll go grab the GoPro camera. Put it in here so I don't have to rely on this crappy live stream footage. Alright, here we go. Pile on the solder. What did I do with the solder? What did I do with it? Oh, here it is. This is probably the least better idea, which is to solder in the Rodin coil, but well, we're gonna solder it in. I'm not recording locally. I should record locally. I'll do that also. But if I get the GoPro in here, I can just set it in a corner in case everything blows up. At the end of the day, no matter what happens, this was a great idea. My concern at the moment is my Rodin coil just going poof, too much power. That's why I want to be able to control the input voltage. So if this gets real hot real fast, I'll turn it down. Look at that. Now that's a sight to see. Inverter connected to the Rodin coil. Oh crap. What's gonna happen? What's about to happen? Okay. So this has to be sort of close. Nothing's connected to the output. I just want to see if I can get the circuit to come on, and I'll feel the coil. The coil will probably warm up. These are all connected in series. I'm going to slowly turn up the AC voltage until this thing kicks on. There's no indication of when it's on. And then I can connect the drive circuit here to the signal generator. Yeah. I need to sleep. I'll watch later. Okay, bye, Steve. I'm going to go grab my GoPro. Be right back. GoPro. We're going to turn it on. It is saying probably the battery. I'll put in a new battery. Turn it back on. Okay. Record this. It says we got 18 minutes left on this card. I'm going to record this in 120 frames per second in case something explodes. So before I start the camera, I'm going to go ahead and get this connected. Wouldn't mind also putting a meter on the output side. This one's rated for 1000 volts. AC. So we got this meter. This meter. We got our signal generator. Not gonna put anything on the output just yet. Wouldn't mind to see the voltage output over here, but I just have to be patient with that. Alright. So, I think I'm ready. Hopefully nothing blows up in my shop. Is anybody watching? Okay. Oh, I don't know how low light works, so we're gonna find out. What you guys are watching right now is either the best idea I ever had or the worst. Either way, I'm gonna do it. So right now I have 120 volt AC variable transformer. I will be connecting that right here to the inverter, which I have gotten out of the microwave in the past video. I've got that connected to the signal generator to turn it on and off and drive it. And I have that connected straight to a Rodin coil. All of the windings in parallel, connected right into where the original coil used to be connected. And yeah, voltage output on that is here, AC output is here, and there's nothing connected to the other side of the Rodin coil at the moment. I just want to see if I can get this circuit to work. So yeah, I'm gonna set the camera maybe, oh, I don't know. I guess this is probably good a spot than any. Well, here we go. Once I get this plugged in. Alright. So AC voltage is on. Alright. I'm going to go ahead and set it to 120 because I want to see if the signal generator is going to be operating correctly. So let's go ahead and turn the output on. Alright, it's at 1% duty cycle. And I see nothing happening on the output on the coil. So let's turn that off. Let's turn this back down. I just want to make sure this isn't hot or anything crazy. Okay. So let's make sure this is connected right. That's positive, this is negative. Now the only difference here is I changed the amplitude to 2.5 volts, so I'm going to change it back to 5 volts because it probably wasn't enough to drive it. So let's bring it back down to like 2% duty. We'll just put it on 10. And we'll go ahead and bring this back up. Alright, and now we'll turn it back on. Okay, output is on. Oh, jeez. Okay. Wow. Alright, well, the answer is it's working. Scared the crap out of me. Okay, now what we're going to do, that was at 15% duty cycle. We're going to set it at 20. We're going to bring, wow, holy crap, tons of ozone. We're going to bring this down to about 20 volts. We're going to see if this circuit still kicks on. That scared the piss out of me. Alright. It's not coming on. Wow, there's a bunch of ozone. And we're going to turn this up until it comes on. Then we're going to turn this voltage back off. Okay. 60 volts is good. Let's try 50 volts. 50 volts is no good. Wow. 60 volts is fine. Let's go back down to 55. It's still working at 55. Let's bring it down even lower to 50. And it does not work. So we'll leave it at 55 volts input. That's great. Coil's not really warm, but man, it's making some racket. So let's turn it on again. Wow, it is doing some fun stuff. I'm gonna turn the duty cycle down to 10. And it's definitely lower power. Let's bring it down to 5. Nothing. 6. Nothing. 7. Nothing. 8. Nothing. 10. Alright. Has to be at least 9 to 10% duty cycle. Alright, I'm going to let it turn on and let it run for a minute. It's not getting hot. So let's turn it on. You can hear the ozone being created. Let's turn this light off. I want to see. I'm going to turn my computer light off. I want to see the ozone. So I'm going to kill all the lights. And turn this back on. Oh wow. It's nice. Let's turn the duty cycle up to 20. Holy cow. Oh, that's the output side. That's the output side creating the ozone, not the input side. Okay, good to know. Turn the lights back on. That means the output side is connected in a way that I do not want. I don't want the output side to do that. So right now we've got input, output, input, output, input, output, input, output. So they're connected like that. I do want to see how much voltage is coming out of there, so let's see that real quick. It's about 30 volts output. So I guess we could connect a load, which is all these lights over here. Let's just do it. Let's just connect it. Let's just see what happens. So that. This is cool because this is a self-tuning circuit. That's why it goes wah. Alright. We are connected. Let's see if the lights come on. You ready? Holy cow. That was bright. And no ozone. And it says we're putting in 1.4 volts AC. Nothing's hot. Okay. Well, let's try turning up the duty cycle. And we're frying maybe the light bulbs? I don't know what that was. Not sure if you guys could hear that. That might be the IGBT getting hot. Let me turn this voltage down to 0 so I can put my finger on there. No, that's not really warm at all. Alright, well, let's turn this back up to 55 volts. Yeah, you did. I'm glad you're still watching. This is exciting. Okay, let's turn it back on. Oh, it turned itself off. Let's turn it back on. That is weird. That's the IGBT screaming. Alright, let's disconnect the load real quick. Okay, so we disconnected the load. Let's see if we get our ozone back. Of course we do. Now, let's go ahead and disconnect this. And let's connect output. And hopefully it's not like way over this meter's range and it doesn't explode. Ready? Oh wow. It says it's reading 2000 volts AC. So, I guess it's oscilloscope time. What do you guys think? Oscilloscope time? Let's connect this very high voltage probe and see what we can see. The yellow one. Oh, that ozone is really putting it out. It's pretty impressive actually how much ozone's coming off that. I forgot to record this locally. Oh well. The ozone comes from the secondary when it's not connected to anything, which is very interesting. Now let's see what frequency it's running at too, huh? Okay, hopefully this doesn't blow up. And don't forget, this is on the lowest setting. Alright, let's go ahead and turn on the measure. We got one on. Here we go. Alright, let's obviously turn that way down. Let's turn it to 500 volts. So the circuit is turning off for some reason with this connected. Let's see if it stays on without it. No, it's acting a little funny. Let's try connecting this meter back up. Actually, let's crank this voltage up a little. Maybe it's pulling the voltage down. That's what it was. Okay. You know what? I think I'm gonna take a video of the ozone happening with the good camera and just post it all by itself, and then tell people to come watch the live stream if they want to see what happens. Alright, here we go. 2.5 kilovolt out. Wow, that's a lot of ozone. It's incredible. You know what I should do? I should connect the... I'm going to connect a real load to this. I'm going to connect these incandescent light bulbs. That's exactly what I'm going to do. Let's see how much time I got left on the GoPro. It says I've got 5 minutes. I'm recording in super high frame rate so I can capture all the moments. Okay, here we go. Make some room. Now, we only got obviously one light connected to this. One switch turned on. So let's connect this. You can see it's load changing independent, which means it'll automatically adjust. This is a bad idea to use the clamps as a connection. Let's try to twist that together. Now, I did not check current draw on the input side or anything yet, but I'm not worried about that. What I'm worried about is seeing if we can get real power transfer through the high capacitance of this coil. That's what I'm curious about. Alright, Rodin coil connected to output. I'm going to go ahead and connect this meter back up because I kind of want to see what's going on. There's the AC output, even though it's probably a high frequency and not an accurate measurement. That's still pretty cool. Okay, here we go. Ready? We have one light connected. Huh. Interesting. Don't really have any output. Like nothing. Let's crank this voltage up a little bit. Do we bump something? We have this is good. This meter should be fine. And the output is connected. Let's open this circuit. Yep. Now let's close this circuit. Alright, so I think I need to turn this voltage down. There we go. Oh, it's kicking off. Let's put more of a load on it. Okay. I can hear it turning on and turning off. It's shutting down. Let's just bring it up to like 50% power. Okay, so it's shutting down on me. I see no signs of that light bulb trying to light up. So it kind of thinks there's like a dead short. I could try putting a capacitor across the output. Let's try that. The whole winding is just the bare ends. No, the whole coil! Where's my GoPro at? 1 minute. Let's just slap a... Oh, it's gonna be hard to just slap a capacitor on there. Okay, I'll stop the GoPro. Yay! I'm gonna go get my other camera, and I'm going to record this crazy ozone output, and I'll crank it up a little bit more. And that way you can see it later. Right now the coil is connected. How is it connected? Yeah. So all coils are connected in series on the output there. Now let's get rid of this load bank for the moment then. I thought that it would light up that load, but alright. Interesting. And what I might need is an LC output, and I don't have an LC output. I just have it directly connected. So, well, you know what? I don't even have this voltage up that high either. Okay, I'll be right back. I'm gonna grab my other camera. Okay, I'm back. I'm gonna make a sort of video about this because I haven't updated anybody on this at all. So I'm just gonna do that real quick. So here we go. What's up, everybody? Oh man, there we go. Now it's a little more stable. So look, I know I haven't done a Rodin Coil update video, and there's purposes for that, and the main purpose for that is that I've been working really hard for a really long time, and I've done a bunch of stuff, and I've accomplished all the goals that I wanted to achieve, and now I'm just in the experimental phase. So you can see there's a capacitor bank back there, and there's just Rodin coils over here and over there, and you can't see them, it's too dark in here, but basically what I'm telling you is I worked really hard and I replicated what I want. If you want to see those videos, you need to go watch the full-length recorded live streams. Everything's in there. And I don't have the time to put together this amazing video and all the little snippets, and I just haven't had time. So basically, I've seen the over unity phenomenon, as I'm calling it, and I will post a picture right now of that phenomenon of measuring the LC circuit versus the input, and you can see right there, you can read these values. Okay, so like I said, I've achieved my goals. I've created ozone. But now I'm in the experimental stage, and I told you I was going to take that microwave oven transformer microwave oven inverter, and connect it to this Rodin coil, and I've done just that. So what I want to show you right now is that this coil is open-ended. There's nothing connected to the output right here, and I've got it connected to the inverter, which is sort of a self-tuning, self-adjusting to load and frequency and capacitance and inductance, and it sort of adjusts it. So this coil is completely open, the secondary. The primary is shorted in parallel and connected right to the inverter board. I have a variable control transformer here that's sitting at about 50 volts. I'll just put it at 60 so we can say it's at 60. I do not have any current measuring at the moment because I don't need to. It's on a 15 amp breaker though. The lights are just sitting here for the moment. What I want to demonstrate is the ozone that this puts out. So I have here adjustment of duty cycle. This is basically power output in wattage basically. So if I adjust this to a higher value, it goes up, and lower and goes down. Okay. So here's what I'm going to do. I'm going to turn off all the lights, and I'm going to show you the crazy output of ozone. The ozone occurs on the secondary, not on the primary input. Okay? So it's on this coil that's open. So I'm going to go ahead and turn off all of the lights. Here we go. Doop. Now, I hope this works. Here we go. Turning it on now. There you go. So let me try it again. So I'm going to turn on the output power. I'm going to turn it up. That is cool. I don't want to burn the insulation, so I don't want to do it too much. I'm going to go ahead and turn it up to 40% of output. Check it out. I mean, that is freaking cool. Alright, I'm going to 50%. Let's see if it kicks it. Oh yeah, see, we're starting to break down things. And I don't want that. That's so cool. I haven't yet got it to put out that much ozone by tuning it myself. So this driving circuit is amazing. Here we go again. Get you a 3D visual here. Look at that. That is just amazing. Alright, I'm going to turn it off. That's crazy. Okay, let me turn the lights back on. I'm actually going to step out of this room. I've got a fan blowing in this space because it's small, and that is a crap ton of ozone. It'll make you sick. So anyway, in case you're wondering, I'm going to go ahead and turn this back down to 10%. Again, I've done all this tuning manually, but this is freaking perfect for this application. And it doesn't have all the safeties built into it like the inverters for induction cookers. That would be the other second really nice thing to use. But yeah. So here's the other one. Alright, so now what I'm going to do is just show you what the output looks like with these LEDs connected. So I'm at 60 volts, I'm at 10% duty cycle. There we go. Ta-da! Now you hear it buzzing, and I do not like that buzzing sound. I'm going to turn the input voltage down to about 55 volts and try it again. So that buzzing noise bothers me. I can get that much light output tuning it manually. I'm not worried about it. By the way, the output voltage measured here is about 2.5 kilovolts peak to peak. I'll go ahead and just show you that since I've got it connected. That's with it turned down, of course. This is with it on its minimal amount. So it's at its minimal amount. If I drop lower than this voltage, it will not work. So I have to have that much input voltage. So let's go ahead and measure the output voltage peak to peak at 10% duty cycle input. So it's all the minimal amount of power that I can put into this system. So here we go. Oh yeah, I gotta turn that way up. So I'm gonna turn this up to 500 volts per division. And go ahead and turn this in. So that's what the signal looks like. Turn this off. You can see the output peak to peak voltage is really kind of going crazy. Here's what I'm going to do. I'm going to pause this. Oh, that's why. Okay. Well, anyway, I'm not too concerned about the oscilloscope right now. I'm not measuring power. I've done all that, like I said, and I just wanted to show you the amazing plasma via the ozone being created, and it's still pretty strong in here. So I'm gonna call it quits with this camera. Let this room air out for a couple of minutes, and then yeah, we'll keep going. But anyway, this is all on the live stream. You can go watch it at rwjresearch.com/live. I've been doing this for weeks on end, in the morning and in the night and all over the place. So, there you go. I'm going to disconnect the oscilloscope. It's so crazy because this is just in series and it's open. So it's just the oscillation in the coil itself. It's pretty amazing. So I'm going to go ahead and show you the plasma, and I'll end on that note with the plasma again because I think it's amazing. Not amazing, but it's freaking cool. I'll go back up to like 40%. Alright, God bless you guys. Have a good day. I've been playing with the Rodin Coil for a while now. Man, that's a beautiful sight right there. I have been working hard on this project. Look, it goes all the way out the end, all the way to the end of the wires. It's just crazy. Alright, peace and love, guys. Bye. Oh yeah, I gotta step outside. Alright, well guys, I've successfully done what I wanted to do tonight. I'm gonna go edit this video and upload it like right now. And that's it. Man, this coil is hot. But which one is hot? Okay, the driving coil is cold. The one that's creating the plasma is hot. So there's your note. There's a MOT in that circuit, right? A MOT? Microwave oven transformer? No. No. You probably didn't watch the whole length of the video I posted about the inverter. That's okay. But no, that's an incorrect statement. What you just said is wrong. It is literally directly driving from this inverter the coil. Man, that thing is hot. This thing is really hot. It's just a switch. That's what I said. That if you watch the whole video, Jeremy, I know it's like a 40-minute video, but play it in the background while you're working, because to be completely honest with you, this is the best circuit I've ever come across that I could just remove from something, simply feed it nothing more than a 220 hertz pulse wave modulated frequency, and it just automatically tunes itself to the inductance capacitance according to the load, all automatically. And as I've shown here today, it's very simple. So I know it's a long video, trust me. Actually, why don't you do this? Jump straight to 14 minutes if you didn't get that far, because from there on out I show the understanding of how this works and how I figured it out, and obviously there's a bunch of data online about it. Now this microwave oven inverter, wow, this thing's hardly hot. 220 hertz. No. See, you gotta watch that video, Jeremy. The 220 hertz input is what the circuit needs as a PWM signal. The output frequency of this is between 20 and 40 kilohertz, according to the operating manual, which also states it's tuned according to whatever it thinks, whatever it's happy with. Alright, I'm going to unplug everything. Make sure this is turned off. I'm going to go edit this video right now. I think this is really, really fascinating. So I'm going to go slap this in there and put in that one image and go to bed soon. Because my wife is still awake, so I want to spend a few minutes with her. Alright, go watch the end of that video. Yeah, it's like a clock input. Alright, I had a lot of fun today. This is the first experiment that I just put together and worked. I told you it was meant to be. And I'm super excited about this because now I have some really, really cool ideas to try. Such as feeding this back in, measuring the current that this is drawing, and just all of those things that I'm supposed to be doing along the way. I gotta get out of this room. The ozone is killing me. Love you guys. Bye.